Our final set of notes deals with classifying matter based on the kind of particles that it's made up of. Now, one of the things that we need to be able to describe matter using are some terms that talk about what they look like, as far as whether they look the same all the way through or if you can see different parts in the material. If something is homogeneous, the word homogeneous simply means that the material is very uniform. It's completely uniform composition. It appears, and I do want to emphasize that, to the naked eye, it appears to be the same throughout. We may know that the material, for instance, takes salt water, for example, or sugared tea. We may know that there is sugar in it, or that there is water in it, and some kind of coloring if it's tea, but if it looks the same throughout, it's homogeneous. So you're looking at things like pure substances, sugar, salt, baking powder. A chocolate candy bar, if it's pure chocolate, like a Hershey's Kiss or a Hershey's candy bar, those would be examples of something that's homogeneous. It's the same all the way through. The air we breathe is homogeneous. Matter, however, that does not have a uniform composition is heterogeneous. If we can see different parts in it, it's heterogeneous. A pizza is heterogeneous. We can see the pepperonis and we can see the crust and the cheese. A Hershey's candy bar with almonds is heterogeneous because we can see the chocolate and we can see the almonds. If we can see the different parts, and take it a step further, if we could separate them into different piles, it's heterogeneous. So salt and pepper would be heterogeneous. We could separate that into two piles. I do not know why anybody would want to do that, but we could. So those are two terms that we need to be familiar with, and we'll look at them more fully whenever you get into my class. We can classify matter as being one of three types of substances. Matter can be either an element or a compound or a mixture. Now, elements are the simplest form of matter. You cannot break them down by chemical or physical means. The smallest particle of an element is the atom. That is the smallest particle of an element that can still be identified as that element. You have a worksheet in your packet that is asking you to come up with symbols for the different elements, and a periodic table that will help you in doing that. And if you see the name of something that appears on that periodic table of the elements, it's an element. Make sure when you're doing that worksheet it says it at the top, but I want to emphasize that if it has two letters in the symbol, the first one is capitalized, the second one is lowercase. If there's only one letter, it's always capitalized. If you mess that up, you're going to miss a whole lot of points on that worksheet. So make sure you pay attention to that. Examples of elements include things like gold, which has a symbol AU. Iron is a symbol Fe. Oxygen, symbol O. Carbon. So all of these are examples, again, of the simplest form of matter. So if you see a single element symbol, you know you're dealing with an element. That's another way to classify it. Now, when you're dealing with a compound, compounds, they are two or more elements that are chemically combined, so they can be separated by chemical means, but only by chemical means. If you have sodium chloride, for instance, salt, that's table salt. That's one good example of a chemical compound. That salt cannot be further broken down except by chemical means. I can't use a pair of tweezers and pull the sodium away from the chlorine. It's homogeneous. just like elements are. Elements are homogeneous as well. They're both, again, pure forms of matter. Now, one thing that's interesting about compounds is that their constituent elements, the constituent elements, for instance, of salt or sodium and chlorine, the constituent elements lose their original properties. Sodium chloride is a perfect example of this. Sodium, pure sodium metal, is a silvery colored substance that will blow up when you put it in water. Chlorine is a yellowish colored gas that will kill you if you breathe it. Yet we put salt on our food, and when we put it in our mouths don't explode, and we don't die from breathing toxic gas. And the reason is because when we put the sodium and chlorine together and bond them together, they lose their original properties. There's something new, there's something different. The smallest particle of a compound is generally called a molecule. We'll get more into some variations on that later. But in general, we think of compounds as being formed from molecules, two or more atoms that are bonded together. Other examples include sugar, which is our table sugar that we put on our cereal, etc., C12H22O11. Those are just a couple of examples of some of our compounds. So if you see a formula for a substance that contains more than one element in it, sodium and chlorine, for instance, in salt, or carbon, hydrogen, and oxygen in sugar, then you know you're dealing with a compound rather than an element. Both elements and compounds are considered to be substances. Substances are pure. They're made up of one kind of matter. They're either made up of all the same atom, or they're made up of all the same molecule. For example, salt is a substance. It's all NaCl particles. Water is a substance because it's all H2O molecules. But salt water is not. Salt water is not pure. It's made up of two different kinds of particles. Now, when we do have something that's made up of two or more different kinds of substances, we have a mixture, our final classification. These substances are physically combined. They can be separated by physical means. So our salt and pepper example from earlier is an example of something that can be physically separated. Once again, I'm not sure why you would ever want to do that with a pair of tweezers, but you could. Their constituent substances keep or retain their original properties. So if you mix them together, you still have those same properties. For instance, the salt water is an example of a mixture. If you put the salt water and the water together, you still have the properties of water, you still have the properties of salt. They keep their original properties. Italian salad dressing would be another example of a mixture. Italian salad dressing would be an example of a heterogeneous mixture because you could see the different parts. If you shake it up, it'll stay mixed, but if you let it sit for very long, it separates out. You can see the herbs, you can see the oil, you can see the water. You can see the different parts. It's a heterogeneous mixture. Salt water, on the other hand, is a homogeneous mixture. Homogeneous mixtures, they look the same throughout. You know there's stuff in there, you know there are different substances in there, but you can't see the different substances. And we actually give those types of mixtures a special name. If they are a homogeneous mixture, they're referred to as a solution.